Welcome to higher degree polynomial functions, where we are going to look at both cubic and quartic functions. This is just first part of the series, and you're welcome. So the first question you are given, you are asked, the weekly revenue for a product is given by R of X equals to 194.4x minus 0.027x squared, and the weekly cost is C of X equals to 9,000 plus 97.2x minus 0.054x squared plus 0.00002x cubed, where x is the number of units produced and sold. First question, how many units will give the maximum profit? Round to the nearest whole number. So first of all, remember that profit is revenue minus cost. So therefore, our profit, P of X, will be R of X minus C of X. So in this case, we are going to take R of X, which is 194.4x minus 0.027x squared, and we subtract 9,000, this is C of X, plus 97.2x minus 0.054x squared plus 0.00002x cubed. So we work out the parentheses, distribute the negative. So this would be 194.4x minus 0.027x squared minus 9,000. And then notice here we have a negative and a positive, that is minus 97.2x. And then this negative and this negative will be positive 0.054 x squared, and then this negative and this positive will be negative 0.00002x cubed. Now, putting like terms together and arranging in ascending order, we start with the cubic term, which is negative 0.00002x cubed. Then notice now the next is negative 0.027x squared plus 0.054x squared, which becomes positive 0.027x squared. Then we come to 194.4x minus 97.2x, you get positive 97.2x. And then notice that minus 9,000 has no partner, so it remains as minus 9,000. So therefore, that is our profit function. So our profit function is P of X equals to negative 0.00002x cubed plus 0.027x squared plus 97.2x minus 9,000. Now this is what we are going to use to find the maximum profit. So we have to graph this. So we are going to do it two ways. We are going to graph using Desmos graphing calculator and also using TI-84. So let's start with Desmos graphing calculator and see what it gives us. So using Desmos, you are going to come here. Our P of X, remember, P of X equals to, or we just call that Y. Let's replace that with Y. Y equals to negative 0.00002x cubed. And then you are adding 0.027 x squared, and then plus 97.2x, and then minus 9,000. So that's what we have. Now notice that we don't see our function here. So what you can do, you can zoom in. You can zoom in so that you see what is happening. Now notice that when we zoom in, we are seeing that our function is gonna start somewhere from negative 2000 for x all the way to around 4000. So if you zoom in, notice that this function is crossing x-axis at between negative 1000 and negative 2000, and then on the right side you can see it is almost 4000. So we can change our window here from negative 2000, we go to positive 4000. And then for y, we can start from, notice that for y, we are still below negative 4000. So we can decide to go all the way down to negative 100,000. And we go to positive 150,000, just to make sure that we get a cubic function. Notice that now that is a complete cubic function. But in this context, since we are actually finding profit, we have to apply some of the standards of mathematics where the answer must make sense, reasonable solution here. And since this is a factory that is making items, the profit, they must have a revenue and a cost. So I know the profit might be negative, but because they are going to make some products, therefore x has to be greater than or equal to 0. So we are going to change the scale for x to start from 0 to go all the way to 4000, and for y, let's start from 0 to go to 150,000. So therefore we end up having this particular function, and therefore to get the answer here for the maximum profit, when do we get profit? When the profit is maximum is right here at the maximum point. So if you point there, Desmos gives you x is 1800, so those are the number of units made, and the profit, the maximum profit is 136,800. So in this particular case, we find that in that case we are able to answer both parts of the question. Part A, we are told that here, part A, how many units will give maximum profit? So it is 1800 units. And what is the maximum profit? We have found the maximum profit here to be, if we go back here, it is $136,800. So this will be $136,800. That is when you use Desmos. And by using Desmos, we have seen that we are using the window x should lie between 0 and 4000, and y should lie between 0 and 150,000. So when we go to TI-84, we apply the same technique. So when we go to TI-84, we are going to go to y equals to and type the equation here, which is negative. So in this particular case, you must be careful how you type your values, because it is negative. So we are going to make sure that we use negative sign, 0.00002 x cubed. So we raise it to power 3. Then you scroll to the right, then plus 0.027 x squared, and then we add 97.2 x, and then we subtract 9,000. Then we come to our window here. We set the window. We said x should lie between 0 and 4,000, and then y should lie between 0 and 150,000. And then you select graph. So that is the function. The graph has been done. So we want to find the maximum. To get the maximum, because the maximum point is where we are going to get the number of items that give maximum profit. So you click second, trace, and then you select for the option. Then we want to set the left bound. So since the maximum is somewhere at the top here, we must tell the calculator, we must guide the calculator where the maximum is. So left bound, we set it there, you press enter. Then it is asking for the right bound. So the right bound should be slightly past the maximum point, and then you press enter, and then the calculator is asking whether you wanted to make a guess, and you tell it yes, make a guess. So the maximum is that x is 1800 and y is 136,800. So x is the number of items and y is the maximum profit, which is the same as the answer we found in the other problem, in the other example. So that is how you work out that. Easy peasy, no sweat. Question 2. Find the cubic function that models the data in the table. So we can straight away use the TI-84 to answer this particular question very comfortably, and it will give us the required answer as needed. Very easy. So what we do in this particular case, we are going to go to TI-84 and we graph this particular problem. So we go to TI-84. There we go. Clear what we have here. So we exit from that. Then in order for us to do that, we go to start and then to our list. Ensure that list 1 and list 2 are empty, or you can use list 3 and list 4 because those ones are available. But for clarity, let's just clear the data from list 2 and we also clear the data from list 1. Then on list 1, we put the values of x. We have -2. Notice that we use the negative sign. Enter, we have -1. We enter, we have 0. Enter, you have 1. Enter, you have 2. Enter, you have 3. Enter, and you have 4. You enter. Then we go to y values. These are -32. Enter, you have -6. Enter, you have 0. Enter, you have -2. Enter, you have 0 again. Enter, you have 18. Enter, and you have 64. Enter. So we have all the data that we need. Now to get the cubic function, all you need to do, go back to start and scroll to calc. And since we want the cubic function, it is represented by option 6, cubic regression. So we select option 6, confirm that x list is on L1 and y list on L2, and we calculate and press enter. Notice that this TI-84 gives you the cubic function, y equals to ax cubed plus bx squared plus cx plus d. A is 2, b is -4, c is 0, d is 0, and the correlation coefficient is 1. So we just know that our A is 2, our B is -4. So everything else is 0. So we are just going to have our function, which will be y equals to 2x cubed minus 4x squared. And that is the cubic function that is represented by this data. You are told to round to 3 decimal places as needed. We don't need to round in this particular case. And that is how you work out that. Then we go to the next one here, and this is the quartic function. A quartic function is that function that has the leading coefficient raised to power 4. Leading coefficient is raised to power 4 for a quartic function. So in this particular case, our problem is we are going to go ahead and use TI-84 in this particular case. So we clear the data here, we go to start, we edit, we can delete our data in L2, clear, enter, then you scroll to the left and then up, clear, enter. So the x values are starting from -2 all the way to +4. So -2 plus -1, enter, 0, enter, 1, enter, 2, enter, 3, enter, 4, enter. And then you scroll to the right to enter the values of y. We have negative 36, enter. You have negative 3, enter. You have 0, enter. You have negative 3 again, enter. You have negative 36 again, enter. You have negative 171, enter. And then you have negative 528, and then enter. So confirm that you have all the data needed, and there we are good. So you go back to start and scroll to the right, calculate. We want quartic regression, option 7. So confirm list 1, list 2, and then you go to calculate, and you can see it gives you the required solution here. It starts by first of all showing you what a quartic function looks like, and then you now go ahead and read the values. Now, one thing you need to know, b is 2.6 times 10 raised to power negative 12. That one is written in standard in a scientific notation, and d is also in scientific notation. So I want to go to the PowerPoint and show you why those numbers, those coefficients b and d are going to be 0. So we're gonna go back to our list. So we come here and notice that we have found that a equals to negative 2, but b, we are told it is 2.6 times 10 raised to power negative 12. So this means this number in standard form, it is 0. We are going to have 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 1, 2. Notice that, and then 2, 6, sorry, not 1, 2, but 2, 6. 2, 6. So that number is as good as 0. So that's why b will become 0. Also, we have c is negative 1, and then d, if you write it, it is written in scientific notation, it is negative 1.5 times 10 raised to negative 11. So that means it is negative 0.10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 5. So that one is as good as 0. So we are going to ignore both A, B, and C, and then we are told E is 0. So E is already given as 0. So therefore, since the quartic function is of the form ax raised to power 4 plus bx raised to power 3 plus cx raised to power 2 plus dx plus e, now in this particular case, our function will be y equals to a is negative 2, so it will be negative 2x power 4, b is 0, so this becomes 0, c is negative 1 times x squared, and then d is 0 and e is 0. So this one simplifies into y equals to negative 2x raised to power 4 minus x squared. And that is the required function. So that is how you work out those. Good, thank you. Subscribe to my channel for more wonderful math problems. Thank you.